Today you will be starting your new unit on permutations and combinations. Before we get into what permutations and combinations are, we have to learn a few things. So the first thing that we have to learn is called fundamental counting principle, and that is the title of the first lesson. So fundamental counting principle helps us find out how many different ways we can organize things. So just as a quick kind of prelude to the unit and to the lesson, we have an example here. It says Hannah plays on her school soccer team. The soccer uniform has 3 different shirts and 2 different pairs of shorts. How many different outfits can she have? So assuming that you can pair one shirt with 1 pairs of short, we can come up with a different option. So I'm going to label these. I'm going to use 1, 2, and 3 for my different shirts, and A and B for my different shorts. So I could pair 1 with A, or I could pair 1 with B. So those are 2 different options. I could also pair 2 with A and 2 with B. And then lastly, I could pair 3 with A or 3 with B. Now I have listed all of the different options, and it turns out that there are 6 options for Hannah to wear. So this is called fundamental counting principle because in this example, there are 3 different shirts and 2 different pairs of shorts. So we can actually get the same answer by taking 3 and multiplying it by 2 to get 6. So you multiply the number 3 by 2 in order to get 6. So that's called the fundamental counting principle, and it is explained to you on the next page of your notes. If there are A ways to perform one task, so this might be, for example, these shirts that Hannah had, and B ways to perform a second task, such as the amount of shorts, then there are A times B ways of performing both. We multiply because they must both happen at the same time. Now, this probably seems a little new to you at this point, but by the end of the unit, you'll remember that if you are multiplying, it means they're happening at the same time, whereas you're adding means that there's 2 different options. So what they mean by happening at the same time means that you wear your shirt and your shorts at the same time. It's not like first you wear your shirt, then you wear your shorts. You wear them both at the same time, so they happen together. All right, let's go on to example 1. A luggage lock opens with a 3-digit code. Each wheel rotates through the digits 0 to 9. How many different codes are possible? So we have a lock of some sort that has 3 digits. Okay, so using the fundamental counting principle, I know that if I'm using the digits 0 to 9, that there are 10 different options for my first number. So 0 to 9, that means 10 different digits. If you don't believe me, count it on your fingers. And then it says if repetition is allowed, that means that I can put the same 10 digits in the next option or the last option. So each number has 10 different numbers that it could possibly be, and then because they're happening at the same time on one lock combination, you multiply them. So for this one, the answer is 1000. All right, now the next one, it says repetition is not allowed. So you still have 3 different options for your numbers. And the first one, there's 10 different numbers, but say you pick the number 9. Now you can no longer pick that number 9, so it goes down to 9 options. And now you've used up 2 different digits, so it goes down to 8 options for your last digit. So we don't really care which number it was per se that we couldn't use, we just care that it was one number. Okay, now we take 10 times 9 times 8 on our calculator, and I think that's 720, but I don't have a calculator in front of me. Okay, so you can see that as soon as you don't allow repetition, automatically the amount of lock combinations you have decreases substantially from 1000 to 720. Next example. This one is your turn. Suppose the code is a 5-digit lock by rotating through 0 to 9. How many choices if there is repetition and no repetition? So pause the video and fill in your answer. All right, here's the solution. The first one, the answer is 100,000, and with no repetition, the answer is 30,240. Please let me know if you have any questions about that. Example 3. Determine the number of distinguishable 4-letter arrangements that can be made from the word English if no letters can be repeated. Oh, sorry, letters can be repeated. So if letters can be repeated, first off, it says 4-letter arrangements. So I know it's going to be 1, 2, 3, 4. And then the next thing I do is count out how many letters are in the word English. So 1, 2, 3, 4, 5, 6, 7. So that means that there are 7 possibilities for the first one, 7 possibilities for the next one, 7 and 7. So this is actually just equal to 7 to the power of 4. So repetition is allowed, so we can include all the numbers there. And the answer there is 2,401. Okay, now the next one says that letters cannot be repeated and there are no further restrictions. So that means I have 7 letters I can choose from in the first option. Then after that, I go down, there's only 6 because I've already used one up. Then 5, then 4. So 7 times 6 times 5 times 4 equals 840. Okay, next one, it says the first letter has to be an E. So now when I lay out my 4 options, I only have one choice of letters to put in the first option. After that, I have now used up the E, so I only have 6 left to pick from. And we're still in the section that says no letters can be repeated. So 6, then 5, then 4. So 1 times 6 times 5 times 4 is equal to 120. So if E is the first letter, then there's only 120 different options. Okay, and then the first and last letter must be vowels. So if there are restrictions that have to do with where the letters are, always do those ones first. So the word English has an E and an I in it, which means it has 2 vowels. So I have 2 letters to pick from for this first spot. But after I use one of those vowels up, I only have 1 to pick from for the last letter. Now, after I've used up those 2, I know that if there were 7 letters originally, that there would only be 5 now. So it would be 5 and 4. So I take those numbers and I multiply them together, 2 times 5 times 4 times 1, and that gives me 40. So not very many combinations where both the first and last letters must be vowels. All right, example 4. A Math 30 quiz consists of 5 multiple choice questions. Each answer has 4 possible answers, A, B, C, and D. How many different sets of answers are possible for the test? So the first thing is that I have 5 questions happening at the same time because they're all in the same test. Each question has 4 different possibilities for the correct answer. So 4 times 4 times 4 times 4, 5 times, will give us an answer of 1,024. So out of those, one of them gives you 100% on the test. That's it. So 1 out of 1,024 chances of getting 100% if you were purely guessing. All right, your turn. An ice cream truck offers 4 kinds of ice cream, 5 types of sauces, and 8 different toppings. How many sundaes can be made? Go ahead and pause the video and answer the question. All right, so you have 4 different options of ice cream, 3 types of sauces, 8 different toppings. Fundamental counting principle tells us that if we multiply those together, we will get 96 different ice cream combinations. All right, example 6. The score at the end of the second period is Canucks 3, Flames 2. How many possible scores are possible at the end of the first period? So, first option is that the score could be exactly the same. Canucks could have had 3 and Flames could have had 1, or Canucks could have had 3 and Flames could have had 0. So those are all the options with Canucks having 3. Then I will do the same thing, but with Flames, or with Canucks having 2. So Canucks having 2, Flames having 2, Canucks having 2, Flames having 1, and Canucks having 2, Flames having 0. Okay, then 1 for Canucks, 1 and 2, 1 and 1, or 1 and 0. And then lastly, Canucks also could have had 0. So it could have been 0, 2, 0, 1, and 0, 0. So if I count those up, there are 12 different options. Another way that you could have got that is said, okay, well, the Canucks, their options were either to have 0, 1, 2, or 3. So there's 4 options. The Flames could have had 2, 1, or 0. So there's 3 options. So we take the 4 and multiply it by the 3, and we get our 12. All right, your turn to practice. Write this down, page 73, numbers 1, 2, 5 to 16, and 19 to 21.